All right, everybody, what is up? I believe we are live on TikTok and on YouTube for some geometry review. That's why I'm going live here. I am that math magician. I'm also known as Mr. Orozco, and I am here just to kind of help you guys out studying for review for geometry. I know that there is a lot of angst and stress with finals week, so I'm hoping I can alleviate some of that with geometry at least. That's my hope. So I have lots of I should mention I have a whole YouTube page full of tutorials. Hello, what's up again? Yes, I see you in the comments. I have a YouTube page. Just a quick little plug for me. I do have a YouTube page full of tutorials for Algebra 1, for geometry. Go check that out in the link to my bio. You'll see so many. Basically all the questions I'm covering today, all the concepts, there's already videos on my YouTube page if you want to look up those as well. But I'm here to sort of help you guys get through this. I want to stream for about an hour. This is my second stream. Yesterday was my first stream. It was kind of fun, so I'm back at it again. And definitely want to help you guys out and get ready for your final. It's final season, and at least in high school. I know some schools end this week. My school goes until next week, so we'll definitely get through that. So let's get right to the math because I want to get going. So these are some of the topics that, at least for my students, are on their finals, right? This is kind of what we explain for geometry for our first semester. And so we have some trigonometry we do. We got sine, cosine, tangent. We got Pythagorean's theorem. We got proofs that we also do. We do lots of flow charts. We kind of figure out are triangles similar? Lots of probability questions. We have angle relationships as well. You got to know all of those, supplementary, complementary, all of those stuff. And then finally, we got some area in there. So I was going to let you guys pick what you want to do. I mean, this is for you. I'm seeing two people want trig. I see that. I also see my aunt is watching. I'm going to say hi to my Auntie Audrey because she's commenting on my live. And then I also saw my parents are also watching too at home. So hi, Mom and Dad. Hope all is well. So what do we need? I saw some trig at first. I see some proofs now. Ooh, lots of people are saying proofs. People are saying I hate proofs. So proofs, proofs are tricky. I get it. Proofs are not fun because it's all like abstract thinking. So why don't we jump into some proofs and then we'll switch on to something else. I'm gonna highlight proofs so I can just keep track. So let's go ahead and jump into this. Let's see. I want to try to find a proof question. I got the whole we got a whole final review packet going on here, and I want to see if I can find where are my similar triangle questions hiding, because they are hiding somewhere in this heap of a mess of a final review. They are somewhere. To the people saying they want to learn trig, I definitely, there they are. I definitely have lots of videos on trig. So if you want to go do trig, I mean, I hope you don't leave. I hope you don't leave my live. But I mean, I get it if you want to. You got to study, right? You got to make sure it's working for you. But I do have lots of videos on trig. So you can definitely do that. Someone asked, am I doing the CPM curriculum? That's exactly what I teach at my school. Yes, our book is CPM. That's what we use. So I'm just going off of what I've been teaching there for a while. So let's jump right into some math because I'm ready. And I got to say, I haven't taught geometry this whole year. I taught geometry for 4 years. This year, I'm on Algebra 1. They wanted me there, so that's where I go. I miss teaching geometry, so I'm actually kind of excited. I might be a little rusty, though, so don't get mad at me if I mess up a little bit. But we'll get there. Okay, yeah, we're going to do some proofs. So the proof that we want to do for this set of triangles here, so we're looking at A here. I have these two triangles. I want to prove, are they similar? That's what we want to prove, right? Are they similar triangles? And we have, and this is kind of hard because I'm on like the portrait mode here. But we need to do basically 3 ways we can solve or show that they are similar. One of the ways is side, side, side similarity. The other is side, angle, side similarity. The other and final one is, whoops, that's off screen, is angle, angle similarity. So my question to y'all is, which one should I use up there, right? Like we have 3 options: side, 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 angle, angle. Which one do you think I could use? I'm going to kind of hide the other one. We're not there yet. How am I going to find these guys here, right? Like what is the way I could prove that they are similar? And I'm seeing lots of you guys say SSS. I always joke with my kids when I did distance learning in geometry. I was like, why do I got all these snakes in the comments? So see, you're going to get final review, but you're also going to get some lame dad jokes. That's what you get with me, right? It's a nice combo. So yes, I agree that it's side, side, side. I'm going to erase these now so I can have some room to show you. There's lots of ways to show a proof. Yes, I like the snake emojis. There we go. We definitely want to use side, side, side. We can use a flowchart, or we can use a two-column proof. Doesn't matter which one we use. I think I'm going to use a two-column proof because I think it lends itself well to this problem. Okay, so, and this is really hard because these are all stacked together. But I'm going to start with my first fact. And the first fact that I'm going to show with this, as I zoom out to kind of show that, is I want to compare some sides, right? I want to find sides that are sort of corresponding with one another. So I'm looking at this side here of ST, right? We see that ST is a length of 9. So I'm looking at ST there. What side corresponds with ST on the other triangle? The other one. We're doing some proofs to prove that triangles are similar. So my question was, I see that that side ST is 9. What side corresponds with ST on the smaller triangle? And I see some guesses there. We got SE, AK, AM. I'm looking at this other triangle there. So which one corresponds? And yeah, I would say KA or AK, right? Whichever way you want to say it. If I'm calling it ST, I definitely would call this guy KA. So what goes in your proof, right? Well, in our proof, what we're going to put, and I got to make my bubble there a little bigger. One way we can write this is we can say that, well, if I take ST and I put it over KA, right? Sort of making a ratio of those sides, right? ST over KA. Well, that would be 9 over 3, because those are the two sides, right? 9 over 3. And then what does 9 over 3 equal? That's the question, right? We want to reduce that. I like that. So some people say they need statement and reasons. There's lots of ways you can do a proof. When I teach this, and I know a lot of the teachers at my school teach it, we like flowcharts. This is the way we kind of do it, right? And so what we're trying to show is, what is the zoom factor? And I saw someone say the zoom factor might be 1/3. It would be 1/3 if I was going from small to big, right? If I go from small to big, big to small, right? Big to small is 1/3, but small to big, that would be 3, right? Boom, we write the 3 in there, and then we're going to circle that. That is our first statement there. Yeah, awesome. I like how some of my students are there. It's all good. They are struggling. My students want to pass tomorrow. I hope y'all pass your final. You got this. Not tomorrow. You take it either Friday or next week. Y'all got it. Okay, let's speed this up because this one actually is a pretty easy problem. This one isn't too strenuous. So let's do the next one. I'm looking at the side SE. Right? SE has a side length of 12. What side corresponds with SE on the other triangle? Yeah, I'm not gonna lie. Proofs are terrible. I mean, when I got to college and I was trying to be a math teacher, there's a whole class dedicated to just proofs. Oh, it was rough. It was really rough, but we can get through it. We can do it. Yes. So SE does correspond with KW, right? So again, in my flow chart here, or in my proof, I'm going to talk about those two sides. So again, I'm going to write SE is going to go over KW. And what does that fraction represent? Well, that would be, right, we're doing big over little. Yep, you said when you divide 12 over 4, it's going to end up equaling 3. Right now, we're confirming our zoom factor. It looks like our zoom factor is 3. We're going to need to go one step further because if I'm doing side, 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 I got to prove all 3 sides. So last but not least, let me pick up a different color here so we can clearly see. And I think some of you guys are seeing this. This one's an easier proof to do. This one isn't as stressful. But yes, Hasna, I see you. TE and AW. You got this. We're going to put TE. We're going to throw that over AW. TE is 18. We're going to throw that over 6. 18 divided by 6 is 3. No real shocker here. Our zoom factor for this triangle is confirmed now to be 3 for all 3 sides. So you're not done with your flow chart yet, right? This is not done with your proof. We've done the side, 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 right? I see you, SpongeBob. I see you, SpongeBob SquarePants. I see you in the comments. These are definitely congruent. Well, what's the last step? We just need to write our conclusion, right? We need to do our conclusion statement now. And our conclusion statement would be that basically these two triangles, they're similar. So I'm going to go ahead and call the first one. Let me zoom back in here. We could call that guy TSE. So we'll say triangle TSE is similar to triangle. And Hassan, I saw it. I think you got it. TSE is similar to, oh, be careful. We're going from T to STE. It'd be AKW. AKW. Oh my God, so good. We circle that on the outside. There's the reasoning, side, side, side. Whoops, I realize I'm not even showing the proof. Ha, that's funny. That right there is your completed flow chart for those triangles there. They are similar. They're definitely similar because they had a flow, not a flow chart, a zoom factor of 3. You got it. Awesome, awesome job. Now that was definitely an easier one. I always say that side, side, side feels like the easier one because usually if it's a side, side, side problem, you can see all the numbers. You can sort of see that relationship. But always double check. That's why we do the proof. Okay? That is awesome. All righty. We feeling okay? All right. We want to do one more proof? We probably should do one more proof. That was a little easier. We'll do one more and then we'll switch it up. I see some people want to trig. Again, I was showing this at the beginning. Some people joined through. And these are kind of the big topics we want to cover. That's what's in this review packet. We got trig. We got proofs. We got probability, angle relationships, area. We're hitting proofs right now. I'll do one more, maybe 2 more. But I do want to hit some other stuff too. I know trig is a biggie for us, right? Trig is a biggie for us, so we can definitely get that, okay? All righty, let me go back into this. Where are we at? Zoop, zoop, zoop. Got to find my triangles page. There we go. All right, let me find a good one for us. All right, let's go to C. I like C. C looks good. Take a second to look at those triangles. Okay, we will do trig. I promise you we will do trig after this. We'll definitely do trig. So take a second to look at these triangles, right? We're thinking, is it side, side, side? Is it side, angle, side? Or is this angle, angle? Which one are we thinking? I think I promised some of my students I would make them a moderator. And look, I'm doing the old person face. I have no idea how to make you guys a moderator. That's what happens when a 30-year-old tries to be on TikTok live. Yeah, I honestly, Hasana, I couldn't even tell you. I couldn't even tell you. It couldn't be me. Couldn't be me. Can't do it. I see you guys, though, saying angle, angle. You are absolutely right. This is angle, angle. Can you guys explain why it's angle, angle? Or I'll flip it. Why can't it be the other two? Why isn't it side, 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 or side, angle, side for this? Can we figure out why side, 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 and side, angle, side won't work for this? Yeah, I'm saying why doesn't it work? Yeah, and you guys are right. There's no sides. There's absolutely no side lengths here. I can't talk about the sides at all. All I have here are angles. Now, are they congruent? We don't know. But we're going to check that out, right? So these are definitely not a possibility. Now, angle, angle, I think might help us out. I hope, well, God, I hope we all can see that this angle is 55 degrees. Angle K is 55 degrees. Well, what is the first fact of this proof? Well, I think the first fact is going to be the measure of angle N equals the measure of angle K. Boom. Right? Excuse me. We're trying to do angle, angle. We're trying to do angle, angle. And we need 2 angles. I only got one ready. I need to find the second one. Now, I thought I saw someone mention it already. I'm going to see if we can find them. Angle M is 72. And unfortunately for us, we have angle P here, which is 53 degrees. And they don't match. Man, they don't match. So what are we going to do to get that to work? Because I can't say that angle P equals angle M. Oh, man, I wish I could. But someone's saying, yeah, angle N is congruent to angle K. We got that one. And I saw Vicious said all add up to 180, so assume you can subtract from 180 from the other two. I like that. So can someone help me get a calculator out real quick? Right? I think what I need to do is I need to discover what angle O equals. That might be helpful. Right? That might be helpful for us. Well, how do I find that angle? All the angles in a triangle add up to 180. So if I'm trying to find out what O is, I can do 180 minus 53 minus 55. What does angle O equal? What does angle O equal? 180 minus 53 minus the 55. Trying to find that missing angle. And I see some people in the chat already got it. Yeah, y'all are getting it. it's going to be the 72, right? Shocker. I mean, I wouldn't say actually shocker because we always got to check, right? We always got to check. Matt's saying 62. Oh, man. Matt, my man, Matt is struggling. Oh, it's all good, Matt. That's why we do this. That's why we practice. It's all good. Not me calling out my students in the chat. Not me using not me. See how I'm doing this? Wow, it's crazy. Alrighty, so we're gonna do the measure of angle M does in fact equal the measure of angle O. This flowchart is done. We can say with certainty that triangle, and let's help me out with spelling this out, okay? Triangle MNE is similar to triangle. What am I going to make the other triangle's name be? Awesome that you find it so easy, Noah. That's awesome. Some students struggle with proofs. These are really hard for some people. Okay? But you got it. What if I'm calling this top triangle MNE, right? Again, trace it, MNE. The other one would have to be called, this is where we're going to get tricky. And I would say follow the angles that I'm using, right? MNE, green, red, blue. If I follow green, red, blue, the other one has to be OKP, triangle OKP. If your teacher is like me, I would definitely knock off some points for that if you're not putting it in the right order, because we got to make sure we're lining up our angles, right? That matters. That part does matter. Awesome. You guys are killing it. What the heck? That is awesome for proofs. All right. How are we feeling about flowcharts? We want to do one more, or we want to switch to some trig? It's up to y'all. This is for you guys. But we did two. What did someone say? I want to see what someone said now. Someone said, how are you teaching on TikTok on a Wednesday before Christmas? Talk about dedication. My students are struggling. They need some extra help. I have this YouTube channel. I have this TikTok account. Why not help them out? Right? We got to do it. Alrighty. I'm seeing, do we want trig or do we want one more? We want a side angle side. Let's see. Maybe do a side angle. I see some trig. I'm trying to figure it out. All right. I'll do a quick side angle side. We'll do a quick side angle side. Trig will move fast for us. Trig always goes fast for us. All right, let's do a quick side angle side. Let me find it. Okay, I see it here at E. Let's zoom in on E. And I actually don't have a lot of space to write here. So we're gonna have to make some room here. Okay? So I definitely want to look at this guy here. Can I make this white? Let's see. I kind of want to blur this guy out. There we go. That's gonna give me a little more space to work. Okay, so I got these two triangles. Looks like a prime candidate for side angle side, right? Why could this work for side angle side? Help me out. TN? What side does TN correspond with on the other triangle? I like that. Nay says, I see this right after I take my geometry final. I'm so sorry. I wish I could have been there before. Man. All right. TN does line up with OB. So if I'm doing it this way, actually, I'm going to flip it to kind of do it the opposite way this time. My first bubble here, let's see if I can get this lined up for you guys. TN, if I put that over OB, the fraction would be 15 over 45. And what is 15 over 45 going to reduce to? What's that going to reduce to? Be careful. TN over OB. That's 15 over 45. What does that reduce to? Be careful, not 3. Because I'm doing it the opposite way. Right? I didn't do big over little. I did little over big. I was doing that on purpose. Making sure them brains are awake on a Wednesday night. What's 15 over 45 reduce to? That's a fraction. Fractions reduce. I see. Oh, there we go. I finally got a right answer there. Brody, you got it. 15 over 45. That reduces to 1 over 3. Now, is the zoom factor 3? It is if I'm going that way, right? If I'm going from little to big, that zoom factor is 3. But the way I set up my fraction is going the opposite way. So the triangle is getting smaller, right? As I move from this triangle over to the little guy, it makes it smaller. So what's the zoom factor here? It's not going to make it big. It's going to make it smaller. I'm doing 1/3. You can do either way. That part doesn't matter. You do it either way. I just wanted to switch it up to show you that you can do that. Okay, that is awesome. Alrighty, let's take care of the other side because sides always tend to be the easy part. What could be my fraction here? You guys help me out. What's that first fraction going to be? Give me the letters. What side over what side? Because we got to be consistent. We definitely have to be consistent here. I did the little over the big, right? Little over the big. So I got to keep with that if I'm trying to show this proof. And I see it. Y'all got it. NE over BX. I'm going to scoot this over to make sure it fits. NE over BX. Well, that is 3 over 9. What is 3 over 9 reduced to? Boom, I see it. G Como has 1/3. Absolutely perfect, y'all. All right, we got the side, right? We got the other side. The last part that I'm missing here, I can't do the third side. I don't know the third side. It's unknown. We got to talk about the angle. And do we have congruent angles here? Hopefully. Ooh, I hope we can all see that. We definitely have equal angles. The measure of angle N, let's write that out real quick. Measure of angle N does equal the measure of angle B. Whew. Y'all got it. So, are they congruent? That's a good question. Are these triangles congruent? Because congruent triangles mean that they are equal triangles, like equal in size. Are these triangles equal in size? Is their zoom factor 1? Because congruent means the two triangles are identical copies of each other. Is that zoom factor up there 1? Because I don't think it's 1. Oh my God, all y'all are saying yes. Is the zoom factor 1? No, right? Because one's bigger, right? The one over here is bigger than the other one. So we don't say congruent, right? The last step here, I'm going to zoom that down. They are similar. And that's the biggie. That's kind of what the whole point of this chapter is. At our school, we're not there yet, right? We're not there yet for congruency. They get to congruency later. Right now, we're just looking at are they similar? And they definitely are. Triangle TNE is similar to triangle what? What's the other triangle going to be called as I show that out? Triangle TNE will be similar to triangle what? This is geometry for those asking. This is geometry, high school geometry. Practicing some proofs. Yeah, y'all got it. O, B, X. We used side, angle, side, congruency as my head blocks it. Don't forget to draw them arrows into our concluding statement. Y'all got it. Alrighty. I think we're good with proofs. I'm not going to lie. We kind of beat the proofs up with a bat at this point, right? We had side, angle, side. We have our angle one. We also have side, side, side. If you want more help with this, definitely go look at my YouTube page. Lots of more videos for you to watch on that. Good question. What's the difference between congruency and similar? Are these two triangles the same size? Do they have the same side lengths? Do those two triangles have the same side lengths? Is their zoom factor 1? No, right? They are not. So they are not congruent. If this had been 15 and this one was also 15, and this one's 3 and this one's 3, then they are congruent because they are identical copies of each other. But that's not the case here, right? Because this one was 45, this one was 9. There was a zoom factor. They are not congruent. But we showed they are similar. They are similar. Okay? Awesome. Someone's asking if I could do another one of these. I'm not going to do one of these. Go look at my YouTube page. I know that's like a shameless plug I'm throwing out at you guys. But honestly, I have so many videos on flowcharts. You will get bored. You won't watch them all. I promise you won't watch them all. There's too many. Okay? All right. We took care of proofs. What's up next? You guys pick. How much time we got? About 35 minutes. All right. What are we thinking here? We got trig. We got probability. We got angle relationships. We got area. What are we thinking here? I'm seeing a resounding, almost unanimous that we should do trig. Let's do trig and then maybe end with probability. I like that. Why don't we do trig and then hit the probability afterwards? We got time. Okay. So let's hit up some trig real quick because trig is always fun. As I search this review sheet, Let's see. Where are my trig problems? Don't mind me. I know I have some hiding here. Okay, we could do, yeah. Let's do, no, those are special right triangles. I don't want to get to special right triangles just yet. Do I not have any trig stuff on here? Ay, ay, ay. Imagine going live and not having, what is going on with this worksheet? Or maybe I just can't find it. All right, you know what we'll do? We'll sidestep. We'll make up some quick problems. I think that that'll be a little easier. So let's do this. I'm going to make a quick triangle real quick. Let's see, is that going to make a right triangle? Ooh, look at that. Perfect. Beautiful. All righty. Let's go ahead. Let me zoom in on that. Let me set this up real quick. And let's make a quick thing for it. I'm looking at the chat. Y'all are crazy. All right, let me make this a right angle real quick, even though it doesn't look like a right angle all the way. All right, let me add some measurements here. Let me call this guy here, we'll call this 27 degrees. And then we'll label this guy over here as, we'll call this maybe X. And we'll do this one as 14. All righty. What could I use here? Right, we're talking about trig. I want to solve for X. We got sine, cosine, tangent, maybe even Pythagorean's theorem. What does this one look like? Sine, cosine, tangent, or Pythagorean's theorem. I'm seeing so many people in the chat talking about their sins. Ay, ay, ay. See what I did there? I'm telling you. I bring jokes to these, right? This is what you get. You get some math. You get some dad jokes. I mean, come on. Ay, ay, ay. All right, this is definitely sine, S-I-N-E. Yeah, this is definitely sine. Why is it sine? Well, look, I have the, don't forget to draw that arrow. It helps. From your reference angle, draw it to the opposite side. This right here is the opposite side. This right here is your hypotenuse. This is definitely sine. Sine uses a opposite and hypotenuse. So we're going to set this up real quick. Sine of 27 degrees is going to equal opposite over hypotenuse, right? SOH, we're thinking SOHCAHTOA. SOH, O over H, opposite over hypotenuse. This is going to be X over 14. This is a good question. Someone said, I thought they could use Pythagorean's theorem on this. Man, we can't use Pythagorean's theorem because you need to know two sides. I don't know two sides, right? I wish I knew two sides. If I knew this third side over here, we could definitely do Pythagorean's theorem, but I don't. So that's why this is sine. So yes, let's go ahead. We're going to multiply by the 14, or you could cross multiply. Either way you do it is going to be fine. X times 1 gives me X. I realize I still have my thing making nice fancy shapes for me. Cross multiply the other side. 14 times sine of 27 degrees. Someone with a calculator, plug that in for me. When we do trig, we want 3 numbers after the decimal point. Go ahead and punch that in. What is 3 questions after, or not 3 questions, 3 points after the decimal point? Your geometry teacher taught you a whole different thing, what, with regards to sine? I mean, because sine is pretty much the same, no matter who's really teaching it. I cross multiply. You could just times by 14. Both sort of get you there. Okay, so I want 3 digits after the decimal sign. And I'm going to punch into my calculator over here. See what we get. Make sure you're in degree mode. We're not in radian mode. Okay. And I'm going to scooch my calculator over. I'm using Desmos for those who need to know. Look at there. 14 sine 27. I'm seeing 6.35. If I was being honest, I think that 8 there is going to round that up to a 6. So this is definitely, oops, that just that quickly. I forgot what I was writing. 6.356. Yeah, that's how we use sine. And if you use radians, then you're on a totally different thing. You want a totally different thing. Yeah. We're not doing radians yet. When they do radians, I want to say pre-cal, they hit up radians. And right now, the geometry students at my school are going, what? What are radians? What is he talking about? We'll get there later. Don't worry about it. It's all good. All right, we feel good with sine? I think that was good. It's a nice little warm-up, right? All right, let's switch it up now. We'll stick with, oh man, and that was what I was trying to avoid. Trying to erase all of these little pieces so I can reuse my triangle. I like reusing triangles. All right, we're going to focus on this guy up here this time. Let's go ahead and make this 71 degrees. Does it look like 70 was? I don't know. but we'll call it 71 degrees. And if that's 71 degrees, let's say I have this as 21 and this as y. What are we doing? Is this sine? Is this cosine? Is this tangent? What are we doing? Sine, cosine, or tangent? First thing is, probably should label. Are you all calling me tan? I mean, I know I'm tan. Yeah, I'm a little tan. See, I'm telling you guys, with me, you get jokes, you get some math. See how that works out? Everyone's calling me tan in the chat. That's all good. I'll take it. All right. No, it's definitely tangent. I agree. It's tangent. See, at least I make myself laugh, right? That's a good sign. Anyway, this is tangent. Why is it tangent? Well, this is our, I see, this is our opposite side. And then we have the other one over here, which is our adjacent side. And what does tangent use? It uses opposite and adjacent. This is definitely a tangent problem. All right, tangent of 71 degrees. In the chat, what is my fraction going to be? Look at I like how my students are the ones that are trying to troll me in the chat. I like that. I like that. See, not the rando strangers, internet strangers. No, it's my actual students. All right. Alrighty. Yeah, guys, right? A tangent, opposite over adjacent. This would be the opposite. So we're going to do 21 over y. You got it. Yeah, it's all good. That's why we practice, right? Get all those mistakes out now. Definitely 21 over y. All right, put the left side over 1. Cross multiply to solve that out. All righty, I'm going to multiply those real quick. We end up with y times tangent of 71 degrees. Why is it y? Y is the unknown side. We don't know what that side is. We're trying to find that missing side. Yeah, we're trying to find that missing side. Yeah. All right, we're going to multiply the other side. 21 times 1. Excuse me. We're in degree mode. We're in degree mode. We are in degree mode. All right, how do I get y by itself? I'm going to try to zoom out to keep showing that. How do I get y by itself? Come so close. I see Vicious got 60.99. We're going to check that out in a second. I want y by itself. Oh, I can't subtract. Good guess. Because there's no addition going on here. But we definitely want to divide by tangent of 71 degrees. Divide that on both sides. Those are going to cancel out. We have just our y left over. And right up here, that's what you got to plug into your calculator. And be careful. Because if you mess that up, then you did all of this work. And then the final answer will be wrong. So punch that in. 3 numbers after the decimal point. Okay, 3 numbers after the decimal point. 21 divided by tangent of 71. And if you're watching this going, oh, I wish he would talk about other things besides trig, go to my YouTube page. Lots and lots and lots of videos covering all the concepts from geometry for the whole semester. Way too many. I'm glad that's easy for you. Some people struggle with sine, cosine, tangent. Yeah, I'm glad you're working out for you. All right, I'm seeing 7.231. 7.231. Punch this into my calculator. And I'm definitely seeing, I'm going to scoot this over, right? There's my 21, whoops, over tan, 71. I think I'm also going to get 7.231, right? That 8 there is going to round up that 1. The 8 rounds up that 1. So it should be 7.231. Boom. Y'all are killing it today. Some of y'all are done with finals. I'm jealous. I still got to teach until next Wednesday. That's our last day. But we're getting there. Slowly but surely. All righty. All right, how are we feeling with trig? Want to keep going? What are we thinking? Because there's lots of more concepts we can do. But if we want a couple more trig ones, I don't mind throwing trig out. A little more? All right, we'll do one more. All righty. So let me go ahead and zoom back into this. Don't tell me what to do, Matt. Alrighty, what if I wanted to do this? What if I had, what if I knew that this side over here is, trying to think now. What if this side over here was 10? What if this side over here was 8? And I wanted to find that missing side. what would I use here to find that missing side? Right? Sine, cosine, tangent? Ooh, lots of people are asking me, what are the angles? There are no angles. So if there are no angles, but I know two sides, we got to be using Pythagorean's theorem. Yes, my favorite theorem. Y'all got it. We got to do Pythagorean's theorem. I was messing with you, making sure you could see it or not. Yeah, you would think it was cosine because I did sine and tangent. It would make sense that the next one I did was cosine. Trying to throw a curveball at you, right? We want to do Pythagorean's theorem. Someone already got it that it's 6. I would argue that this is a Pythagorean triple that you should know. But if you don't know it, Pythagorean's theorem is your best friend. A squared plus b squared equals c squared. The biggest part where students mess up is their c, right? What is the c? What's the hypotenuse? That's my quick question for you. What's the hypotenuse? What side is the hypotenuse? Because that's important. What we end up putting here for c, that's the big part. The a and b, those can be swapped around. That part doesn't matter. But the c's got to be locked in. And the c is the 10. Yeah, c is the side of a 10 because that is the side opposite of the right angle. That is your hypotenuse. You got it. All right, so it's going to equal 10 squared. Like I said, doesn't matter what we do with the other ones. So I'll put x squared plus 8 squared. These are nice round numbers. We should be good. Someone asked, how long have I been a math teacher? I'm currently in my 5th year of teaching. Yes, my 5th year of teaching. Pretty crazy. All right, we're going to keep going through this. We got 64 equals 100. Someone's saying, wait, I think it's actually 36 now instead of 6. Huh? I don't think that triangle would be possible if it was 36. Let's see. How do I get x squared by itself? How do I get rid of this 64? I don't want that on it. I want to move it to the other side. So how am I going to get that out of there? I want to get rid of that. To get rid of 64, I'd have to subtract it, right? So we're going to subtract it real quick. Let me get a red pen. I always like to show subtraction with red. Subtract, subtract. Those go away. So we got x squared. It equals 100 minus 64. That is 36. And some of you might be like, oh, that's our answer. We're done. X is 36. But be careful. Yep, I'm seeing in the comments. Be careful. We can't. That's not our answer. That's x squared. I want x. Right? I don't want x squared. I want x. So we're definitely going to have to square root both sides and make this x equaling 6. Awesome. Oh, look at my student over there saying, can I get extra credit for being in the live? What do you guys think? Throw it out to all the people watching. Should I give my student extra credit for being in the live? What do y'all think? Is that something I should do? Y'all got it. I see everyone guessing 6. Y'all got it. I should give her extra credit? Can I be honest with you guys? I'm also the leadership teacher at my school. I don't even have her for geometry. She's my leadership kid. I should give her points for leadership? Okay. I'll give her leadership points. All right, I'll give her a little extra something. Since she's trying, right? She's trying. So I'll give her that. All righty. Sounds good. All right, let's do one more real quick. Only because I noticed that I didn't do one of these, and we definitely should do one. I'm going to throw a theta in there. We want to find the missing angle. Okay, we're going to need to find the missing angle on this one. And what happens if I know that this side is 7 and this side is x? Ooh, it can't be x because that's too many unknowns. We'll make it 10. All righty. How could I solve for theta? Right? Theta is the missing angle. How could I possibly solve for that? As you guys type that in, don't forget to follow. I mean, come on. My goal today was to hit 20,000 followers on TikTok. I did a live last night and got like 500 extra subscribers. I was like, what the heck? So don't forget. Don't forget to subscribe, right? Subscribe, follow, whatever the word is. Make sure you're in it. Yeah. All right. What am I using here? Sine, cosine, or tangent? What do we think? Sine, cosine, or tangent? I'm seeing some people say cosine. I think it's definitely cosine. And let's set it up real quick. Cosine of theta is going to equal, help me out, what's the fraction? What over what? I see it from Ian. Ian's got to the second step before I even finished the first step. But you got it. Cosine is adjacent over hypotenuse. Well, here is my adjacent side. Here is my hypotenuse. Our fraction should be 7 over 10. Absolutely perfect. I want theta by itself. Well, how do I get theta by itself? I have to do inverse cosine, right? I got to do the inverse of cosine in order to get that there. Awesome. All right, plug that into your calculators real quick. What is the inverse cosine of 7 over 10? And as always, 3 numbers after the decimal point. We always want 3 numbers after the decimal point. Y'all got it. We got to do inverse because we don't know the angle. We're not trying to find a side, right? We're not trying to find a side here. So we have to do inverse cosine to find that missing angle. Yeah. I'm saying 45.573. Is that what we're thinking? Let me go ahead and write it down real quick before I check. 45.573 seems to be what we're thinking. Let me hit the inverse cosine real quick. Inverse cosine on my calculator, 7 divided by 10. And I think y'all totally got it. 45.573. Awesome, awesome, awesome. Y'all got it. I'm not going to lie, though. If I saw this on the final, I would give you guys half a point off for this answer. Why would I give you half a point off? You were my teacher, or I was your teacher. I messed that up. But I don't know who you are, but I was glad I was your teacher at some point. I love teaching. Why would I have taken a point off of this? Theta equals 45.573. Why would I have taken a half a point off? Oh, a tree got it. Not the rounding. I don't care about the rounding. The rounding's fine. But there's no degree symbol. What are our units? We always have to have units. The units are theta. We got to make sure we put theta in there. Yeah. So don't forget that, right? And unfortunately, I'm not gonna lie, y'all. It's hard to get a perfect score on a math test, right? It's really hard because there's lots of steps that you're trying to find. And if you mess up, like if we forget this little theta sign over there, all of a sudden you just lost half a point. So take your time, double check that you're doing everything right because y'all got it. Y'all definitely got it. Okay. All righty. Oh, Husner, where are you going? I see you have airplane. That's so cool. Awesome. All righty. We feel good with trig. Can we move on? What time is it? 7:42. Kind of running out of time here. Yeah, if you got perfect scores on math, you're on it. You're on it. If you got perfect scores in math, that's great. It's tough though. It's hard for some people. And that's why I'm trying to help y'all out. Where were you this Monday? I was teaching. Definitely teaching. Alrighty. It's 10 p.m. It's actually almost 8 o'clock here on the West Coast. I'm in California, the West Coast. Alrighty, I think we're ready to move on from trig. So y'all help me out now. We got a couple more. We got 15 more minutes. I can probably hit one more. Which other ones would you like to do? Is Algebra 2 hard? Algebra 2 is an extension of Algebra 1. So if you find Algebra 1 hard, you might find Algebra 2 hard. Because it's just an extension. All right, what are we thinking? Probability, angle relationships, area. I feel like I'm seeing more of probability. I think probability is the one that's sticking out there. Yeah, all right. We'll hit up some probability so we can help you with that. Awesome. All right, let's go ahead and we'll go with a little, we'll start with number 1. This is going to be really hard because it's hard for me to show the whole thing because it's written on a piece of paper, so I'm going to have to slide. But let's hit up number 1. Number 1 says, if Keisha has 4 favorite shirts, she's got a blue, she's got a green, a red, and a yellow, and 2 favorite pairs of pants. She's got 1 black and 1 brown. How many different favorite outfits does she have? And what's the best way to count this? So that is an interesting question, right? She's got 4 favorite shirts. She's got 2 favorite pairs of pants. We want to figure out how many different outfits she can possibly make. How can we represent this? Someone asked if I'm at school. No, I'm at my house. I am not at school. Absolutely not. Someone's saying to use an area model. Someone said it's just 8. Okay. I think if we make a quick area model, we'll clearly see what it is, right? And again, some of you might know it's 8. You could do a tree diagram. I don't think a tree diagram is needed here, but we can do a tree diagram in a second. So let's do a quick area model. Make a quick rectangle. Okay. We'll have one side represent the shirts. We'll have the other side represent the pants. Now, and I know it's kind of hard with this. How many pairs of pants did Keisha have? Or you could just multiply. Yeah, we're getting there. This is a nice stepping stone to like actually what you're supposed to do with the harder problems. But yeah, we have 2 favorite pair of pants, right? So I'm going to draw a quick line real quick. One of them is black and the other is blue. Awesome. How many shirts did she have? Let's scroll over here real quick. How many shirts does she have? She had 4, right? She got a blue, green, red, yellow. And I'm too lazy to write that all out. So I'm just going to write blue, green, red, yellow. I'm going to draw this out. That's a visual representation of how many shirts, or I'm sorry, not how many shirts, how many outfits she can make, right? There are 8 different outfits there. Some of y'all already figured it out and we're like, oh, just take the 4 times the 2, you get 8. We're going to make more complicated questions in a bit. So this is a way as a stepping stone to kind of get there. But there are definitely 8 different outfits she can have. All of those representing one option. Yeah. Awesome, awesome, awesome. Alrighty. The other pair was brown. Was it brown? Oh, it was. It was black and brown. My bad. I can't read. Don't mind me. Alrighty. Hopefully that kind of helped you out with that. We good? We feel okay? I can move on. How much more time we got? About 10 more minutes. You were right. You were absolutely right. Yeah, you had it. You feeling okay? All right. I'm going to move on to the next one. Alrighty. Let's go to here. Number 2 says, in a bag, there are 4 red marbles, 6 green marbles, and we got 9 yellow marbles. So we got this bag full of marbles. We want to know what's the probability of pulling a red marble. What is the probability? So that's there. So I know there are 5 red marbles, but I want to know what's the chance or the probability of me pulling out a red marble. We wouldn't say the chance of me pulling out is 5 marbles, right? When I say probability, I'm looking for a percent or I'm looking for a fraction. So who here thinks they know what that fraction would be? I think it's going to incorporate 5. Okay. So there are 5. Oh, was I saying 4 red marbles? It sounds like me, honestly. I probably was. I can't keep track with what I'm saying. I think we're going to use 5 in the fraction. What would I put 5 over? Oh, y'all are killing it. Oh my gosh, because there's 20 marbles total. So 5 plus 6 is 11. 11 plus 9 is 20. So all together in this bag, there are 20 marbles. So we have 5 over 20. That is the same thing as 25%, or 1 over 4. Yeah, that is awesome. That is so good. You guys did so good with that one. Okay, what's the chance of me getting a green or a yellow marble? Okay, we just switched it up now. What's the chance of me getting a green or a yellow marble? Someone said 30%. Someone said 70. Someone said 75. The other person saying 75. This one's a little trickier, right? So I want to know what's the probability of getting a green and then getting a yellow. Another way to think about this is if I want to know what's the probability of getting green or yellow, isn't that the same thing as saying what's the probability of not getting red? Does that kind of make sense? I want the other two options. I want either green, I want either yellow. That means I don't want red. So if I don't want red, and red is 25%, what's the other percentage going to be? What's left over? If I have that 25% out, I don't want that 25. The only part that's left over is, I think that's kind of clicking for you guys now, is definitely 75%. Because I'm just taking it, 100 minus 25 gives you the 75%. Sometimes we can use our brains and we can think about questions like that, right? Not necessarily, I didn't show any work, right? There's no really work for that because I knew the 25% is the red. I don't want the red, so 100 minus 25. I mean, now that I'm thinking about that, technically, I think the work you would show for that is 100 minus 25%. I probably would want to see that. Probably, yeah. Alrighty, of course, no worries, y'all. I'm happy to help out. What's the probability of getting a green marble? Why is there a 2 by my username? I don't know what that means. What's the probability of getting a 2? Probability of getting a 2. My brain's not on. This is what happens when you teach all day and then you try to tutor after work. I want to know what's the probability of getting a green marble. What's the probability of getting a green marble? All right, Jacko's saying 6 over 20. Is this 6 over 20? Right? I think it is going to be 6 over 20, right? There are 6 green marbles. I'm running out of space here. 6 green marbles out of 20. That is going to reduce to 3 over 10. 3 over 10 is a fancy way of saying 30%. You guys are doing so good. Awesome. Now look at the last question. The last question says, what's the probability of not getting a green shirt? Did it take literally 52 minutes for someone to comment on my shirt? Man, oh man, I wore this thing. And I was like, oh, someone's going to comment. Have you not seen this shirt? Shout out to my parents. They bought me this shirt a couple years ago for Christmas. Math is easy. And the joke is, let me stand up real quick. Oh, it's a trig problem. It's a Pythagorean theorem problem. It says to find x. Well, they just circled it and said there's x. I think that's funny. Alrighty. You guys are right. If I don't want the green marble, it was 30%. It's definitely going to be 70%. You know what? I will tell them right now, Matt, to my parents, because I think they might still be watching. My student said thank you for the pizza today. Yeah, my parents stopped by, got them some pizza. My parents are pretty nice. Yeah. Awesome, y'all. All right, how we feeling? We feeling okay? I probably got time for one more. Want one more probability question, or do we want an angle relationship question? What are we thinking? Stick with probability? I probably got time for like one more. What are we thinking? We want one more probability? Okay, I think we do. And I think that's actually a good point for question 3. So for question 3, it says Eliza, she shows up to make daily events into games of chance. And she wants to go buy ice cream at the local ice cream parlor. And she created 2 spinners. So basically, she made her spinners, one for the flavors. She can either do vanilla, tutti frutti, or chocolate. The other one is a cone or a dish. Now, the first have 3 options. The other one has 2 options. We want to find out what's the probability of her getting tutti frutti in a dish. That is the question that we are trying to figure out. So, how could I possibly figure this out? She's going to spin this spinner. She's going to spin that spinner. And she wants to see what's the chance of it landing on tutti frutti in a dish. So what do you think we could do? I'll do one angle problem after this. Don't worry. I got you, Jem. We got you. Don't worry. Someone said 1 in 6. So I think if we wanted to do an area model, I think it might be 1 in 6. But if we want to do an area model to kind of show this, I'm actually going to kind of blur this out, this other question real quick, to kind of help show you guys. Let me blur this out. I think if we do a quick area model, it might help us understand that. So let me go ahead and make a quick area model. If you're doing this at home, hope you do that too. Let's start off with the ice cream flavors. We'll make this guy up top the flavors. We have three flavors. We got vanilla, we got TF for Tutti Frutti, and we got C for chocolate. What's the chance of me getting one of those flavors? Oh, good question. Why don't I use permutations and combinations? Because we're not there yet. This doesn't need it yet. And the students that are taking first semester, they're not there yet. But they'll get there. That's in second semester. And right now they're probably going, what the heck is a permutation or a combination? I don't want to scare them just too yet. No worry. I'm glad that we're all getting you prepared. So what's the chance of pulling out one of these flavors in that spinner? What's my fraction? I'm looking for the fraction. What would the fraction be for all three flavors? What over what? What's the chance? What's the chance of me getting one of those flavors from that first spinner? I spin it. What's the chance of me getting vanilla? What out of what? What do we think? Yeah, 1/3, right? There we go. 1/3. I think all of them are 1/3. That's going to come in handy later on. I think for the cone or the dish, right? Here's the cone. Here's the dish. Hopefully that's pretty clear that both of those are 1/2. So here's how an area model can help you visually see it. Again, this problem is a little easier because all of the fractions are the same on the top. All of the fractions are the same on the side, right? So it makes this one a little easier in the sense that you're not dealing with all these random percentages. So when I look for Tutti Frutti in a dish, I'm looking at that space right there. That shows Tutti Frutti in a dish. Well, how do I find it? That means I need to take 1/2, I need to take 1/3, and I need to multiply those. I got to multiply those. And 1/3 times 1/2 is 1 out of 6. There was someone saying, yeah, just do 1/2 times 1/3. You got your answer at the beginning. You're totally right. But this helps kind of visually see that, right? So you can see exactly why it's 1/6. You got it. Awesome, awesome, awesome. Alrighty, y'all. I got like 3 more minutes left in this live because I'm getting tired. I got all these lights on me. I got this green screen behind me. Getting ready to get out of here. But I want to get going. I want to do one angle relationship problem for you. And for the angle relationship problem, I am such a fan of this one right here. Right there. That's the one I want to do. I'm going to erase this one underneath it. Tell me quickly in the chat, what is the angle relationship shown with those two angles? What is the angle relationship shown in those two angles? Someone said I didn't do the tree diagram. Go look at my YouTube. My YouTube has it. My YouTube has tree diagrams. I posted a playlist on my Instagram. Go do it. Ooh, not corresponding angles. Not corresponding angles. I got 2 lines intersecting, opposite angles. We call those, starts with the V, vertical angles. Now here's the real question. You got the name. Okay, who cares about the name? What about what's the definition behind vertical angles? What does that mean is true about those 2 angles? What do we know about those 2 angles if they're vertical? What does it mean? It means that they are congruent. It means that they are equal, however you want to spin it. That is exactly true. So we're going to say that 5x equals 125. I want to solve for x, right? Vertical angles are equal to each other. So I can solve for x now. Divide both sides by 5. X equals 25 degrees. Don't forget the degrees. Y'all got it. I see you in the chat. Lots of you guys saying 25. Awesome. Look at me. I got 1 more minute. We can do one more. One quick one. Let me find a quick one real quick. I like this one. I like 28. Y'all got it. Y'all got it. Yes, it is easy. Y'all got it. All right. What about 28 here? What's the angle relationship with those 2 angles? I got this red angle over here. I got this blue angle over here. Ooh, super fat. Don't want it that fat. Bring it down a bit. They are supplementary, so they equal 180. My chat is killing it right now. You guys absolutely got it right. So that means I can say that 10x plus 2 degrees plus the blue angle, 128 degrees, we know that they make a straight line. Since they make a straight line, they equal 180 degrees. Let's see if we can solve for x real quick. See if we can solve for x. I'm going to give y'all about 1 minute as I get ready to shut this live down. And make sure, before you log off, got to make sure you subscribe to me. I got so many math tutorials, Algebra 1, Geometry. I also made some math raps. I got to do the quick plug. I made some math raps. Go look at my math raps. Come on. Alrighty. What do we get for x? I'm confident if you're in a geometry class, you can combine like terms and solve for x. What does x equal here? I'm seeing some people say 5. I think it's going to be 5 degrees, right? I think it has to be 5 degrees, right? Because what's 2 plus 128? That would give you 130, right? Subtract the 130 from both sides. 10x is going to equal, whoops, don't need to write that. 10x would equal 50 degrees. Divide both sides by 10. You got your x. X does equal 5 degrees. Awesome, awesome, awesome. So I heard some people say, can I do statistics? Can I do AP Calc? I would be so down. I wish I had the time. I just currently don't have the time to make a whole bunch of videos for other ones. I'm planning going live later this weekend for Algebra 2. For those who still have finals for Algebra 2, I will go live later in the week for Algebra 2. I'll even come back and do another geometry if y'all want more geometry. But definitely check out that before y'all leave. When am I going to do a live again? Probably. So I was going to do it tomorrow. I'm going to be honest with you. I'm a big 49er fan. The 49ers are playing tomorrow night. I can't miss the 49ers playing. So I'll probably do Algebra 2 on the weekend. I'm thinking Saturday or Sunday. I'll post about it. Okay. Alrighty, y'all. This was so fun. I enjoy going live with y'all. And we'll definitely get a schedule going so that we can do more lives like this. Can I do proofs for geometry? Go look at my YouTube page. There's so many. So many on there. I promise you. So many. Thank you. I appreciate the W teacher comment. Can I post about this? Yes, of course. I will post about this as well. All right. Bye, everyone. It was fun. Good luck on your finals. Y'all got this. I'll see you next time, okay? All righty. Bye, guys.